So today we're going to cover section 3, and today we're going to learn how to use angle bisectors of triangles. So the first slide has the angle bisector theorem. And this theorem states that if a point is on the bisector of an angle, then it's equidistant from the two sides of the angle. So this is the angle bisector theorem. So if AD bisects BAC, then that tells me that DB is perpendicular to AB and DC is also perpendicular to AC, which are the sides of the triangle. The sides of the angle. And then you can state that DB is congruent to or equal to DC. And what we're going to be looking for is that it has a perpendicular symbol here, that it's got a right angle. That's going to indicate that it's going to be the distance. Because again, remember, the shortest way to get across this river would be the perpendicular distance. So we need to look for the shortest way to get to the sides of the angle. And that distance between each would be equal. This one, the converse is just backwards. We're going to flip the order. So the converse of the alternate interior and the corresponding stuff, that's to prove lines parallel. But this converse is just the reverse of the words. Those are the if and the and switch. So here it says if a point is in the interior of an angle and it's equidistant from the sides of an angle, then it lies in or on the bisector of the angle. So point D would be in the interior of this angle, BAC, and then that tells me that point D is equidistant from the sides, so it's equidistant from the sides of angle BAC, and then we know that because it lies on the interior and it's equidistant, because we got the congruency marks, then we know it lies on that bisector of the angle. And the bisector is AD. Okay, next, another theorem. This is the concurrency of the angle bisectors of a triangle. So we're talking about the point where the three angle bisectors meet. So the angle bisectors of a triangle intersect at a point that this time is going to be equidistant from the sides of the triangle. Remember yesterday, they were equidistant from the vertices. Now this one is equidistant from the sides. So each one of the blue lines is telling me that PD is equal to PE, which is also equal to PF. Okay, so the point of concurrency here is point P, and that is the point where all of the angle bisectors meet. The angle bisectors are the red lines, okay, or the red segments. In this figure it is, okay. On your test, it's not going to be in color. So what this lesson was angle bisectors. So notice all of those red lines are the angle bisectors. Notice they're coming out of the vertices. This is the angle that they're bisecting. So if you want to put congruency marks in here, so you can tell that they are the angle bisectors. The point where they meet is called the point of concurrency. That point on the next slide is called the InCenter. From that InCenter, we can see that that point is going to be always equidistant from all three sides of my triangle. And those are going to be the blue lines. So the blue lines are the ones that are going to be equally distant from each of the sides. Okay, so if I told you that this side here, PD, if I told you this was 3, then that would tell me that PE is also 3, and so is PF. Now the lengths of the red lines are all different. The only ones that are equal are the ones that go from the point of concurrency to the sides. And they're the perpendicular distance. So the point where those three angle bisectors meet is called the incenter. The point of concurrency of the three angle bisectors is called the incenter. It always lies inside the triangle. Remember the circumcenter, depending on the type of triangle, its location moved. When it was acute, it was in. When it was right, it was on. When it was obtuse, it was out. This one is always inside the triangle. So like in center, so inside the triangle. This figure, the circle, is said to be inscribed within the triangle. So it's inside the triangle. So it's inside or inscribed within the triangle. Yes?
Can you refresh my memory?
Now we'll apply these theorems that we just learned. So here, first example, it wants us to find the value of x. Notice those two angles, they're the same. This tells me that that angle, the big angle, has been bisected. So I know that I just learned that when we have an angle bisector, that the distance from any point on that angle bisector is going to be equal. So if this is 15, then this one is 15. So x equals 15. This time, they showed me that the distances were congruent or equal. We also see the little right angle here. So this tells me that this is a distance. And it's the shortest distance from that angle bisector. So this tells me that this angle has been bisected. So this angle is congruent to this one. So I will set 3x plus 5 equal to 4x minus 6. I'm going to solve for x. Move the 3x over. 5 is equal to x minus 6. I'm going to add 6. And x equals 11. It didn't ask me to find the angle measure. It just said find x. We have one more example. Again, still applying the same things. So again, notice I have two congruency marks here on my angles. So this tells me that this angle has been bisected. So then again, I've got the perpendicular distance. And I know that these distances are equal, so I will set them equal to each other and solve for x. So 6x minus 5 equals 5x. I can move my x's together. Doesn't matter which way you move it. I don't want a negative 1x, so I'm going to divide. So x equals 5.
So which wait, in the last one we were using the converse?
No, we're using the angle bisector theorem. Any other questions?
Wait, on the last one, the two angles at the bottom are equal?
Yes.
Oh, they look different.
Well, it's the same. It's only, they both have a single mark.
Oh, I see.
You see that? So, yes, they're not lined up perfectly. I think the reason why they moved it down a little bit, because if they would have continued this all the way across, you wouldn't have been able to tell if they were talking about that whole angle. So that's why they sort of separated it. Now, if this one would have had 2, then they wouldn't have been congruent and they wouldn't have been bisected. Okay, so they just moved it a little bit just so you could see that, yes, it had the same single red line to show that they were congruent. That makes sense? All right. Okay, so your homework is 5-3. So when you come in tomorrow, you're going to do the 5-3 warm-up. We'll go over the homework, and then we'll begin reviewing for the quiz. Again, maybe go back through the lessons tonight. Make sure that you have everything clear of what to do for each type of theorem. Again, the quiz is going to have a lot of calculations, so be able to apply all the definitions and theorems.